In the roughly 1 year run-up to the Cygnus demonstration flight, we were in a situation where Cygnus was largely finished, and the Antares launch vehicle, as well as the Wallops pad, were still trying to catch up with us and be ready. And so we had the benefit of having quite a bit of time to run both internal rehearsals and bilateral and trilateral joint mission simulation tests, JMSTs they're known as. And we did many of those. And we did more than anybody had ever planned. It was, I would call it, was beyond budget testing at that point in time. And those JMSTs were incredibly valuable in terms of preparing all parties in the mission for the mission. It got everybody well versed in how to communicate. By the simulation team throwing multiple anomalies at the mission at the same time on all levels, anomalies in the Cygnus, anomalies in the space station, anomalies in how the environment runs. Those stressed the team but prepared the team because it taught them how to operate in that type of environment. And then on the day we flew, the first couple of days for the mission were actually pretty benign. Not that much happened. But on the day we rendezvoused and didn't rendezvous, sure, there was a lot of stress, but the team handled it extraordinarily well. Nobody got upset. Everybody did their job. The control team, both in the control center here in Dulles as well as the control center in Houston, kept managing the vehicle as it flew by under the ISS, and then we had a team that was offline, our anomaly resolution team, that immediately jumped in and started working on the anomaly. So those rehearsals were super important. I didn't really appreciate them in the beginning because they seemed very dry and so a lot of people talking to each other on a net. But in the end, it got everybody well prepared for the day that things didn't go perfectly. Contingency planning for a new mission is incredibly important. We spent quite a few hours putting together lists of candidate procedures and candidate, specific rehearsal scenarios that we could run to be ready. I think what comes to mind are a couple of contingency scenarios and procedures and rehearsals that were important and did pay off. One was the rehearsal of aborts and what you do after the system aborts. Quite often in these JMSTs and simulations, you're actually planning for success. You're planning to get the vehicle to its capture point, and you're planning to get it captured. But for a variety of reasons, sometimes through faults in the simulation environment or sometimes by design, Cygnus aborts away. So the team just proceeds on and continues the simulation with Cygnus aborting. We proceed to go through all of the activities, to pull up the procedures, to go do what's necessary to fly Cygnus in that scenario. And so taking it up a level, the meta-level contingency procedure is abort. You need to have those procedures for aborting because they envelope a whole variety of things that could happen that lead to abort. So the team must rehearse that. We did rehearsals associated with racetracks and racetrack burns. That's another one where the contingency is if Cygnus doesn't get to the space station, well, how do you come back? And how soon do you come back? And what maneuvers do you have to execute to come back? And how do you do those maneuvers safely in the vicinity but not actually in joint ops with the space station? And so that's an important contingency. How do you after you abort, how do you get back to the space station, line up with the entrance point to joint ops, and do it all over again? A third contingency that I would say is a meta-level contingency because it can handle a lot of different things that might occur would be software patching. And in Cygnus, this was a particularly challenging thing because we have multiple congruent processing flight processors. But we did plan ahead for how to patch Cygnus. This was one of those contingencies that struggled to make the cut because we kept trying to convince ourselves that we'd done such a thorough job for testing software that this just couldn't happen. But then we found ourselves on the day with an issue where we had to patch a line of code in Cygnus, and we were prepared because we had done some preliminary work for how to go conduct a patch. And then in the 2 or 3 days, up to the point where we actually did the patch, we were already on orbit. In that 2 or 3 days, we went offline. We ran more simulations on our high-fidelity test beds. We did more work on the test procedures using our INT team that were very familiar with operating the vehicle. And we crafted a very specific contingency procedure for doing a software patch. And that all went very smoothly.